Hi, I'm Dave Robinson, Chief Data Scientist at DataCamp, and today I'm going to be recording a screencast of analyzing a dataset that I've never seen before. So this is I'm doing this is the third screencast I'm recording, and I'm doing the latest Tidy Tuesday. And the one thing I know about this dataset is that it's a set of R and R package downloads. So let's dive in and see what we can find out about this data. Now, all right. One thing I can say is that the previous two screencasts, I'd never seen the data before. Here, I have seen very similar data. I'll share that. In fact, I made a Shiny application out of it, where I allow people to visualize package downloads in Shiny. And I don't even know if the app still works. It was at least 3 years ago. But that's just some disclaimer up front, is that I'm going to be analyzing data that I certainly didn't prepare for today, but I am at least a little bit familiar with. Maybe it'll work, maybe it won't, but let's take a look at what the data is and what we can find out about it and what kinds of explorations we can do. So, looks like we have 7 columns, a date, a time, size of a download, the release of R. So this is downloads of the R language. Oh, I'm wrong. I thought this was of R packages. This, I think, is of the R language. Okay, that's cool. I haven't seen this actual data before. I looked before at package downloads over time. Oh, and my old Shiny application is broken. Good to know. So I'm going to start with, here we have 1 year and we have 1 day. Okay. Let's start by looking at what the 2 different types of data are. This one's 54 megabytes. Last Tidy Tuesday. This one is much smaller. Let's try starting with the full one. Does it mention? So these are, so this is package, this provides this we have here is both the actual data for the R language in terms of how many downloads there are, and some ways to get data at a package level. Or we might play later with package level, but let's start entirely with the R downloads data. I'm going to start with the 1 year. I'm going to be a little ambitious. So whenever we start with the download, we would grab this URL. I'd create a new R Markdown file, and I'll say R downloads year read CSV. I'd neglected to do library tidyverse read CSV, and I put in the URL. This is going to be a little slow if it's 54 megabytes. So while it runs, oh, that's a little surprising. That was pretty fast. Is this the right data in terms of a year? Well, we see data going back to October 23rd from last year. It's probably pretty okay. All right. Version, OS, country, it's a country code, and IDs. So that's anonymized data. So I've got an extra X1 column. I don't remember how I probably just want to drop that right away. Select. I'm going to have the R downloads year raw data as one step, and then process in a separate step. I'm going to say remove that first column, which just has row names that we really want to ignore, and work from there. So this is downloads of the R language. All right, so then we have, here's some downloads of 4.2, downloads of older ones like 3.0.3, what operating system. All right, lots of interesting things to find out. It's here's a 2-letter country code. We're going to be learning how to change that into today I'll show how to change it into a country name, which might be more readable. And this is anonymized data, so each IP gets an ID. I couldn't know exactly what the person's IP address is, but probably if we counted the same person multiple times, they did multiple downloads, we would see their IP ID pop up multiple times. So let's start by Let's start by doing the processing. Let's say our downloads year. Remove the first column. Maybe we'll do more processing later. And notice we have a date and a time. Sometimes we might want to combine these into a date time column. I don't think it's that important right now. Let's start with changes over time. So if I'd say count date, I now get one observation for each date. And anytime I have something over time, I'm always going to look at a line graph. All right, so we first see, so when I have a line graph, I'd like it to start for the y-axis to start at 0. Makes it a little less misleading. We see our weekly trends. Absolutely no question. We spike probably in the middle of the week, drops on weekends. And that's the first thing I notice. The second thing I notice is we have a big increase starting around, what would that be? June, July, no, there's July, late September, early October, big increase in number of downloads of R per day. So is that real or is that an artifact of the data? It's something we might be interested in. We also have a big spike right here. Sometimes spikes in data like this kind of download data, are real. They could be a Coursera course that launches and tells everyone to install. But often they're not real. Often they might be, let's say, someone was testing the installation, so they did 1,000 installations on one day, or something like that. So we're not 100% sure. Nothing's standing out as crazy. There's no one day that is 100 times higher than any other day. But we're starting to understand this is a good first graph. I'm even going to throw in a number of our downloads per day line here, and this could be an actual graph in our end analysis. So I'm going to quickly say theme set. I like to set a non-default theme, and I like to save the file as our downloads. All right, so right now I know how many people have been downloading R. We see dip in late December, makes sense. Now that I have this by week, I might want to look at it. Two different ways. I might want to look at it in terms of what's a typical pattern on a weekday. So in terms of what day of the week, I want to decompose this into a weekly trend and then the overall trend. So I can start with the weekly trend by actually, if I load up the Lubridate package, and then I say count weekday equals W day of date, label equals true. I love the W day function. It'll actually say the number of downloads per day. And I can actually graph that if I like. Weekday and N. Always have an expand limits y equals 0 here. And I'll need a group equals 1 in the geom line to connect them. This is a really typical pattern we see. We see it in a lot of web companies too. Peaks on Tuesday and Wednesday, dip on Friday, and then a big dip on the weekends in terms of I just realized I did a count. I actually probably want an average. Average equals mean of what I would need to do actually is count by date and then take the mean of n, now that I'm thinking about it. I need to say average downloads per day. And then I could say downloads per weekday. So now we understand that if I want to summarize this in a sentence, I would say a typical, I might say R is downloaded about 1,500 times each weekend day and around 3,000 times on a typical weekday. That's averaged out over the last year. So that would be how we understand week trends within a week. But now that we know that, we can actually make a better graph. I'm going to keep that graph there, but I probably would drop this one. I'd rather aggregate it by week, so so we don't actually have this spikiness, so we can look for real trends. So what I would do is, instead of counting date, I'd count week equals floor date by week. That's a great lubricate function for aggregating over by windows of time. I also, whenever I aggregate by week, I definitely need to drop the incomplete weeks. So I usually just do filter is week is greater than the minimum week. I would often filter out the maximum week, but I'm starting to have a suspicion this data set actually ends, perhaps it ends on a Saturday, because that final week, let's find out, it ends on it ends on October 20th, 24th. I believe that is a Saturday. Yeah, that was a Saturday, so I actually don't have to drop the last week, but I dropped the first incomplete week. And now what we see is, if we look at by-week trends, that choppiness has disappeared. I change this to per week. And we instead see it dips in September, and we have a real increase in around September. All right. That's fun. This is a solid graph. We learned something about change over time. We're going to want to look into this jump. It's kind of a suspicious jump. I'm going to zoom back out and look at the data set. Here's the data set. I want to know... Let's look at country. Yeah, we're probably going to return to version and how it relates to date, but let's look by country. So I almost always, when you have a column like this, a categorical column, will start with a count. And here we have, I can tell you from knowing two-letter codes, this is United States, China, Germany, Great Britain, India. That's really interesting. I actually, I think I would have guessed that India was higher and China a little lower. I'm a little more accustomed to Stack Overflow data where India is the second heaviest visitor. Having said that, I do know that India, while it's extremely heavy visitor of programming sites, both Stack Overflow and DataCamp, my two recent jobs, had India as their second most visited country. India doesn't lead in terms of data science and use of languages like Python and R. That other countries are overrepresented in those. So it looks like it's United States, then China are two of our top ones. I really I don't want to stick to these two-letter country codes. I'm going to use a package called country code. It's a really useful a package that does one thing and does it well. I'm going to say country equals, and what I'm going to do is run, there's a function in this package called country code. Just happen to remember, I believe it goes, you give it the country code, you give it the source, which in this case is, I'm going to say it's ISO2C country.name, from and to. Oops, it's not that, it's origin and source var. This should have been country. Much better. All right. So we have country, and now we have United States, China, and so on. What was right after Canada? Okay, we do have some missing data, but it looks like we also have A1, A2, AP. I understand what EU might mean. It could mean European Union. I don't know what the others would mean, and it's worth knowing. It's worth remembering. There's a few countries we're less confident in. This might just be some missing data. But if I were going to make a graph out of this, I would probably take the top 16 and then follow a really common pattern. If you've been watching these screencasts, you've been seeing me do the same thing, where I say take the country, take the N, coord flip it. And we reorder the country. We say country is FCT reorder country by N. I'm probably also going to filter not is in a country, and I'm going to do that before I do the take the first 16, and it lets us get closer to this. Here we are, this number of package downloads. And when I do a number, it makes me, I realize that I actually might rather say N divided by sum of N. And I probably want to do that now that I think of it before I filter out, definitely before I take the first 16, that otherwise it would be misleading. And I'd say take percentages, then take only the non-as in A countries, then reorder this by percent, and then have percent on the y-axis. And anytime I have percent on the y-axis, I like to get into the habit of saying percent. I'm going to load up the scales package earlier. So that I can say what percentage of each country does our package downloads come from. I'm missing one. Oh, it's percent format. It's close. All right. Solid graph, I could polish it more. I could probably throw in a title like what countries install the most are. You know, it's not too exciting, but it's a list. It looks like a lot of it is United States. I would note as like a top level, I'd say more than a third of our installations come from the U.S. It's something worth noting. All right. Next step, I'm going to look a little bit at, I'm actually going to look a little bit at version. Version's going to be a bit interesting because we're going to see some serious trends with time. Over the course of a year, we can say count version, so it equals true, always count first. 81 different versions of R were installed. Now, I'm suddenly noticing there's a latest, which is separate. You can say latest, and I don't know if that means the other ones aren't the latest version. I don't think that's what it means. I think that it has to do with, maybe it has to do with how someone clicked on the install button or how someone got to that page. It is from the CRAN mirror. I don't know how to distinguish latest from each other type of version. That's just worth kind of noticing. All right. Now we have 81 types of installations. Anytime I'm going to want to graph these over time because I have a suspicion if we look as soon as an R release comes out, we're going to see that starts being the one that gets installed. Not always. We're going to see people install older versions, but there's a very strong time trend. So once I think that way, I think that what I need to do is do a FCT lump on the version. Let's say only include the top 7, and then everything else will be other. And then I get to say, let's count date and version, and now make a graph of it, where I say date and color equals version, and I bet I'm going to see a trend where we see like all the new package. Oh, look at that! Doesn't that look great? I think that looks great. We just see like back in late 2017, almost all installations were of 3.4.2. Then they were all of 3.4.3. Then they were all of 3.4.4. Then 3.5.0. Then 3.5.1. All right. I also see other has been popping up here. Right at this moment. I bet that's one of those ones, that patched one, that I was ignoring in this list. Because I think let's throw in one more result here. One thing I love about this is an alphabetical. I love version numbers because this color is listing as alphabetical, but that's actually the list we wanted in because that makes it also chronological. All right, so something changed around, what would this be, September 2018, where we did see an increase in 3.5.1. We also see there's a patched version that gets released and people start installing. And we see a jump as well in people installing latest. I can actually, if I want to get a better feel for each of those, I could facet wrap by this. I meant by version. There should be 8 types in other. And here it is. We see that patched, latest, other each show a jump in the last couple months. Earlier versions, what we see is like there's a constant underlying stream of people installing an old version. Then there's 3.4.2. Then you see our typical ones where something gets released, and then afterwards it's very rare to install it. We have our patched version, our latest, our other. All right, that's pretty interesting. Okay. I'm going to, All Are you interested in hour? I'm interested in time of day. I'm interested wondering when are people installing R. I'm a little interested in both time of day and weekday. I think those kind of aggregate pretty well together, but it's not the world's easiest thing to graph that. I'm going to start just with what time of day. I'm going to say, let's see, I already did the graph of per week, and say what time of day were people installing R. And I'm going to say, all right, I'm going to take our R downloads year, count hour of time. I'm going to guess this is UTC. There it is. It's UTC. That is universal time. It's I don't remember if it's exactly the same as Greenwich Mean Time, but it's if it's not, it's pretty close. And it's a basically it's a European time zone. We'll keep that in mind when we examine changeover, how it depends on the hour. And I'm going to expand, and almost any time I look at almost any time I look at time, I want a line graph. All right, here's our burst. We see it's lowest around UTC midnight. That's time 0. And it's highest around UTC. This would be 14. This, I can tell you, is the window when America starts waking up. So here's where Europe is waking up. 6 a.m. Europe, 7 a.m., 9 a.m., 10 a.m. That's where we're seeing Europe wake up. And then later we see the U.S. wake up, and that's where it really peaks. We have country data in here, so we can divide it a little bit down. We can actually, we got hour here. I'm also going to have country. I'm going to do it with, I'm going to use my country code line. So if we want to confirm what times of day do people install R, I would say, let's throw in a country. I'm going to mutate this first. And then I'm actually going to FCT lump it. And I'm also going to filter not is in a country. That graph looks terrible because I haven't faceted it yet. Facet wrap by country, and we get 9 graphs of trends over time within countries. I thought I filtered not is in a country. Oh, but I need to do that after I do the change it to a country name. Yeah, I'm really interested in like trends over time here. I'm not as interested in the absolutes, so I'm gonna put the scales on a free y-axis within this facet. Now we get a feel for time zones, and yeah, we really do see no one's installing R in the middle of the night. This right here is middle of the night. UTC is basically England time, so we can see no one in the middle of the night is installing R like 2, 3 a.m. And then we peak around 10 a.m. to the afternoon, and then it drops back down. We see the workday is higher. This is a pretty typical trend. The U.S., notice the dip isn't as deep because it covers at least 3 time zones, 4 more if you count Hawaii and Alaska, and as a result, there's some spread out, like when some people are waking up, others are going to sleep, and other, of course, is spread out all over the world. So we see here's some trends, yeah, and that gives us a feel for installations. I am immediately interested in this China trend. It could be because these could be major cities in China that are in different time zones and spike. I'm not that familiar with how many time zones does China cover. It could be something else. It could be automated systems doing particular kinds of installations. But this 3 peak pattern is something I notice in terms of how China's standing out here. Huh. Okay. So that was a story of time of day. We looked at date, we looked at time of day, we looked at version and how it links to date, and finally we might want to look at what operating system do they use? System do our users use? So I'm guessing there's only a handful of operating systems: OS X, Windows, and Linux, maybe Ubuntu, maybe SRC for installing from source. Vast majority installed, not vast majority, but a majority installed for Windows, some for OS X. It's rare to install it from source. If I had a lot of time data, like if I had it over 5 years, I'd probably look at the change in OS distribution over time. I'm not so sure that's important here, but I'm that we're going to see anything, so I might skip that. But one of the things I notice here is I was kind of thinking that a lot of these might have been automated installations on a server, and it's starting to look like that might not be the case. Most of those would probably be installing from source, and we're seeing only, let's take n divided by sum of n. That's only about 5% of our installations are installations from source. All right. Could look at a lot of interactions here. I could look at country by operating system and find that some might use Open OS X more than others. Some might use install from source more than others. I'm not gonna. I'll take it back. I'm gonna take a look at OS over time, and for a very specific reason. I'm interested in this pattern of it going up in October. I wondered, is that limited to a particular, I wonder, is this limited to a country? Is it limited to an operating system? I kind of want to dig in a little bit and just figure that out. Where did this spike come from? So I'm going to start with operating system and week. Once I realize that I'm doing, I take it back. I was going to say I can process week early on, but it's not that hard to copy this line and say week equals floor date of week, and count by operating system and week. And now I can say, we're going to wonder, does this spike come in a particular operating system? We saw that it didn't come in a particular version. A lot of them were 3.5.1, though some of them were also installing from latest. And I'm going to start by saying week and color. I'm going to, just like before, I'm going to say filter, don't include our first week because it's a partial week. I'm going to say color equals OS. No, I see a spike in Windows installations. I see a spike in OS X installations. I might even see I think you see a spike in installations from source, though it's definitely less noticeable. So it's not one particular OS that is driving this recent spike. Could it be one particular country? Definitely worth finding out. Let's ask. I'm not even keeping this graph because it's not interesting. This result, I'm gonna go ahead and say count. I'm gonna bring in that mutate. Now's where you've seen me do this before if you've watched the other screencasts. Now's where I decide one step. Getting the country name is going to come in the earlier, here in this first chunk. So I'm going to say, let's grab the country name out right away. And here now I can just say, in this step, I can say country equals FCT lump. Let me say country name, FCT lump of country name with 8 levels. And say, I'll start with color equals country name. And, aha! We definitely see that we didn't used to have we used to have basically no missing data in terms of a country name. But now we have this big chunk of NAs that's suddenly popping up. Now we do also see a spike in, this will be the US, this will be other. We definitely see those spikes, but what's the story of this missing data? One possibility is that maybe they started, this data started reporting a bit differently and started reporting, let's say, I don't know, EU data altogether, and that's where we were missing the EU data. I am going to try doing this on country code instead of country name and see if see if there's a particular common country that spikes up. No, it was originally this NA data. Let me see. I'm confirming. Yeah, there's some data. There's actual missing country data that's only started coming up in this one point in time. Whatever it is, I'm going to be very cautious about this recent increase. I don't think it's real. I don't think that it represents an increased interest in R. It might be real in that it represents, let's say, our studio started making the default having a feature that allowed you to install R by default from the cloud, but from the RStudio CRAN mirror. It could be something kind of a real download, but it's not like more people using R or anything like that. I'm going to be very cautious. Okay. All right. Finally, I'm going to take a look at IP addresses. So in particular, taking a look at this anonymized set of data. Oops, where did I do sort equals true? Right here. That should not have. That was an accident left over from a count. Much better. I have these IP IDs. I can say some people have probably installed R once. Some people have probably installed R 20 times. If I count IP ID, I get, all right, one IP address, and I know it's a person, it could be an automated system, has installed R 7,000 times. Well, that's something. Huh. Some people, and we see this, I'm guessing if we did a histogram, we're going to see a really long tail, where a handful of IP addresses install lots of times and some install a smaller number. Now, we do see a long tail here. Some people install it many thousands of times. But it's also worth noticing there are loads and loads of IP addresses, loads here, that are installing. This will be hundreds of times. I didn't expect that. I expected a very clear mode around 1. My bet, though I don't know for sure, is that these are going to represent people that, when I say people, but systems that install it once a day. Because once a day over the course of a year, around 365, we'd be seeing 2,000, 1,000. Yeah, 365 would fit into this bar. Twice a day would fit into this one. It could also be companies that all use the same IP address. It could be a lot of things. So let's find out. And I bet if we clean this a bit, I bet if we remove some of these, maybe some of the trends will become clearer. So let's take a look at. We have R downloads over time. I'm going to leave this in. What if instead of saying how many times did you install it, actually I take it back. What I'll do here is I'll look at one IP ID. This was IP ID 1. That happened to be the first IP address ever used. I saw that in the data earlier. If I say filter IP ID equals 1, let's look at one IP address and how many times have they installed R. Change from Spain to United States right away. That's a little strange. Usually IP addresses, you wouldn't expect them to change. That's a little surprising that I'm seeing all these different countries popping up in the same IP address. I really wouldn't have expected to see that. What if I look at another IP ID, 7? That was the second highest one. Does that one appear in lots of different countries? Mostly US, sometimes others. Yeah, I'm not sure how they're getting country if they're not getting it from the IP address. So this surprises me a little bit. And they could, data source could be getting it from the browser. Might have a country field that it's using, that it's learning from it. But it's worth noticing. I'm also noticing a lot of these IPs are in your first couple of IP IDs. That means they were one of the first installations. That could just be by chance, like, well, if you get installing a lot, you're going to often be one of the first few. But it's making me really, it's making me wonder, like, IP ID 2 is often United States, sometimes South Africa. This is a bit confusing. I wouldn't have expected the data to be shaped this way. I really would have expected some people to be installing it every single day, maybe once a day, but I would have expected them to be mostly unique to a single country. So I'm not sure what to make of the IP ID. I wanted to look at some things like I want to look at some things like how many people come back and install R later, but I'm not sure I can with this data. But I'm going to take one more. I'm going to take one more try of looking at this. I'm going to say, let's see. I'm going to look at the gaps within each IP address. I'm going to look at the gap in the date time between one installation and the next. That means I actually need to combine the date and the time. I haven't done this before, so I'm going to, let's find out if it works. I'm going to find out if I can add a date and a time together and get a date time. I cannot. What if I said what if I change the date to, CT or LT? I never remember the difference between those two. Oof. Well, that looked like it worked, so I feel pretty good about it. So what I'd say is nope, I feel terrible because this is not UTC time. That should be 14:29. It accidentally changed to EST. Does LT look any better? Yes. And I don't remember the difference between LT and CT. And I'm not going to look it up now. So I'm going to, okay. Time zone. All right, I'm just going to use this because it looks pretty good. It looks like here's my date time, and here's the right 2:29 p.m. The reason I was doing this is I'm really interested in using a window function and saying group by IP ID. Let's make absolutely sure we're arranged by date time. If we're not, we'd be in trouble. And then we'll say group by IP ID and say gap equals, and what I'll do is say date time minus lag of date time. So it's going to be NA for the first few because we didn't, these would be like, they installed the first time installation. There wouldn't be any gap. There's no previous installation. But we get to here and we say, aha, this person, 913, this IP address, had already installed R 21 seconds earlier. So I'm going to filter not is in a gap. So I'm going to say among people who install it twice, what's the distribution of amount of time between installations? Time between installations. The reason I'm interested in this, I wonder things like, do we see a pattern of IP addresses installing twice exactly 24 hours apart or close to that? Do we see a lot of people that install only every 3 months or so when a new release comes out? All really interesting questions to me. So I'm going to save this as R download gaps because we did some processing of it. And I'm going to do one more thing. On this gap, I'm going to do as numeric to turn it into a number instead of a time of a, what do you call it, a time, like an interval object, because I'm really interested in getting it in seconds. All right. Now I'm going to look at a histogram. This is a numeric column, so I want a histogram, the gaps. And I'll say gap, geom histogram. Anytime you look at time, you're basically always going to want it on a log scale. And I've got a really cool trick for making this an understandable log scale. You can see why I want to do it on a log scale is we see a clear bimodal distribution. Bi-log modal distribution. Bimodal log normal distribution. Fantastic. What we see is 2 peaks on a log scale. Now, these are not helpful axis labels. I have a trick that I like to do with this scale x log 10 on time specifically. What I like to say is, let's choose our breaks carefully. Have them be 60 to the power of 1 to 4. That is to say, that'll be, 0 to 4. That'll include 1, 60, 3600, and then much larger numbers. Why did I choose these? Because I can then set the labels. What is 60 seconds? Anyone? What is 1 second? It's 1 second. 60 seconds is a minute. Another 60 is an hour. And these are evenly spaced, which is kind of handy. 60s are kind of awkward to work in, but it's quite convenient here that on a log axis, second, minute, hour, 60 hours is 2.5 days. And another 60 times that is 120 days. So here we have our modal distributions. Most gaps between two installations on the same IP happen either at about in between a minute and an hour. So it's like multiple installations an hour is what we're looking at here. Wow, that's not good data. That's not what I want to be looking at. That's not that important. Or we have installations that happen between an hour and 2.5 days. This will be about a day. In fact, I might even add a V-line and say color equals red, LTY equals 2, and the x-intercept is 86,400 is the number of seconds in it. 86,400, I'm pretty sure is the number of seconds in a day. Let's quickly check that math. Good, yeah, that's the number of seconds in an hour. So, boom, bunch of people installing, a bunch of IP addresses installing exactly once a day. Now that we know that, we might want to go back and change some of those earlier graphs. In particular, it wasn't a great idea to say number of installations per day, since sometimes the same IP address installing again and again and again within minutes or even seconds of each other. We might instead have preferred to look at distinct IP addresses installing each day, or in fact each week. I like the idea of distinct IP addresses installing each week because it's going to be, this is probably an automated system. This is probably someone who's installing R once every single day. So now over here we have our distribution of people who might install only when a new version comes out, that are separated by weeks, months. That's also worth noticing, but this IP ID, it's really starting to make us realize how we can clean up our data a little more and possibly be more meaningful. What I would do, this is again assuming we can trust IP ID. I'm a little nervous with the issue about countries. Same IP address being in multiple countries. I don't have much I can say about that. So what I'm going to do is when I say back here, I counted by week and got the number of R downloads per week. I'm going to change this. I'm going to group by week and summarize the number of distinct IP addresses. So I'm going to say N is N distinct of IP ID. This is like our, quote, weekly active users graph. And this would show, it's not counting the same IP address installing again and again every minute or every hour, every day. It's only counting within a week the number of distinct IPs that download. And here, there's a lot we notice. One is we still have this spike. So this spike was not caused by the same IP addresses installing more and more frequently. We still have this spike in, April, May, May or June or so. We have this spike in installations. We still have a dip for the end of the year. That's where there are holidays in many Western countries. And it's actually, in some ways, it's a messier looking graph, which might actually be meaningful. Maybe our graph used to look flatter than it was because these IP addresses were underneath installing every single hour and making the graph look more regular than it is. This graph of the gaps, I would put in an appendix, and I would title it Appendix Why Count Only Distinct IPs. I would show this, and then I would say, if we take a look at this graph, I would observe, not this graph, it's this graph. I would drop this one, and I would say, what I would say is, IP counts. I'd create a data set of that, and I discover an easily summarizable fact. For example, what fraction of our IP addresses installed more than 100 times? Wow, a majority of IP addresses majority of IP addresses that installed are majority, and then I would say in my little text here, I'd say make a percent out of this, of IP addresses that installed are did so more than 100 times in a year. I could learn a little bit more about this number. Right now it's 63%. If I change it to 200, it goes down a little bit. That might be a good observation, is half of IP addresses more than 200. I like 63% more than 100. But yeah, it's generally like once you're more than 365, you're talking about once a day installers. So it looks like there are a lot of IP addresses that are installing again and again. That, or we can't trust the data. It's a little hard to say in this case. Yeah, it's really hard to say if you can trust the data here. But the but looking at distinct IP addresses might be more meaningful. Okay. All right, we have about 15 minutes left. I wanted to take a look at the package level downloads, just because I think this is really neat. This is really neat data. So what we have is, let's pick one day, maybe. I've looked at changes over time, but let's try picking one day and downloading, let's say yesterday. This is not yesterday. I think this is 2 days ago. I am running this on Monday the 29th. And if I do a copy link address, we can say our package downloads. Package downloads. I've looked at it before over time, which is why I'm going to take a look just at one day and see what we can learn. One day, the 27th. All right, so we have is, I think this is just from one source. Is that right? This is just from our studio. It's the cran.ourstudio.com. Okay. And it says anonymized described at the bottom of the page. I don't see anything at the bottom of the page. It's okay. And what I'd say here is set package downloads. Nope. This data is not package downloads. Because if it were... Oh, I see. I accidentally went to the link for daily R downloads, which is the same data we were already looking at. Okay? So what I can look at here is instead this date. Oops. I like that they give some code to download, like a range of time. But given how long this one's taken, I'm not going to bother with that. They have the great API package cran logs if we wanted to dig deeper. All right, so let's take a look at one day. And we have a date similar to the other data. We have a date and a time. We have package size, our architecture, and this is package version. Then we have countries. Okay, so I usually want to look at packages. I want to say count package sort equals true. I'm going to give some guesses. I bet RCPP is going to be very close to the top because it's depended on by a lot of other really important packages. Some of the tidyverse like ggplot2 and dplyr are probably going to be up there. Also, a couple other packages that form this backbone of a lot of packages. Maybe stringr. Okay. All right, what I see is RCP near the top. I didn't know Erlang would get more installations than that. This is a tidyverse package that's dependent on by a lot of others. I don't know what WGCNA is. I never heard of that package before. All right, this is probably a data artifact because while I'm sure it's popular, it's not. There's no way that this naturally got this many installations. This is probably, let's say, some system that happens to be installing it many thousands of times or something like that. Everything else here is pretty much what I'd expect. String which the stringr package is built around, and both those, a lot of packages depend on them. I think digest is some maybe ggplot2 uses. Really, dependencies are a big part of this data. Anytime we look at number of package downloads. Okay. But mostly understandable. WGCNA is just very strange in this case. All right. I'm kind of interested, actually. I don't know if anyone else is. I'm interested in what package country connections. So if I counted country, let's find out if the data is still kind of clean. See, what's interesting here is that while India was not the second most downloaded, like in terms of our downloads, it is pretty high on the list with package installations. I don't know what to make of that. I don't know what the difference necessarily would be. Okay. But what we'll do here is, I'm a little interested in is, are there some packages that differ? Let's see. Let's say US and India. They're the two countries that pop up most in this data. I'm wondering, are there some packages that are more installed in the US versus some that are more installed in India? That just happened to be one question that popped in my head. You're looking at this data, you might be interested in something different. Definitely, I'd say go for it. I'm going to say, let's filter just for the US and India and count both country and package. Then what I'm going to try is a spread. I spread country into two columns, each of them containing n, and I say fill equals 0. Now that I've done that, I want to have my total column. The US plus India is going to be your total number of package installations, and I probably want to arrange in descending order of that column. Now I say between the two, most had Erlang. I bet some other country had the WGGNC package that was popping up. That was from somewhere else. So now we have India and the US, and a total between them. I'm going to turn each of those columns, India and US, into a percent. Heck, while I'm at it, I could throw in more countries, but I won't. I'm going to say total is US and India, and then India is IN divided by the sum of IN, and US is US divided by the sum of US. To say what percentage of installations do they make up, that will allow us to compare between them. And now I can add another column called ratio, where I say India, let's say US divided by India. One last step. I'm not going to use to get the percentages, I don't like them being 0 because then it'll look infinite. I'm going to add 1 to the numerator and denominator. This is a typical pattern. It's called Laplace smoothing that will keep the really low numbers, like if there's 0 and 1, it won't look like an infinite ratio. The numbers for the top couple packages end up looking almost the same. But I'm just going to make sure these percentages are 1 plus your number of occurrences divided by 1 plus the total. So now what I'm seeing is, for example, YAML is much more installed in the US than it is in India, about 60% more installed. But DevTools is much more installed in the US than it is in India. That's interesting. Whenever I look at a ratio, one thing I might want to do is sort it. I'm probably going to need to filter by the total column. So this, for example, has a 191 ratio in terms of installed many times in the US, basically never in India. But it's not the most installed package overall. That's actually, I take it back. That's a lot of installations. This data might be kind of messy. It might not be distinct IP addresses. Oh, that's one thing we're going to do that'll make this data a little bit better. I'm going to look at country and package and summarize N is distinct IP addresses. I neglected to do that before, but there might be one computer installing this a lot. If we assume we can trust the IP addresses, this might be a bit more interesting. And some group by country, package, and distinct. Something is wrong with the data. Okay. Arrange by. I need to ungroup after this or before the spread, but I needed to ungroup. Group by had left it sorted. All right. So we have some packages, count and NSME. I'm not familiar with these, that are much more installed in the US than India. It's different data once we were cleaning it. But it's still, a lot of these are generally small packages. Let's try filter. The total is at least 1,000. Let's say you have at least 1,000 packages. Now, what are your ratios? Okay, this ends up with 100 packages. That works for me. It's like 100 packages that are pretty influential. Sure. And it looks like our app DIRS, which I'm not familiar with, but I am familiar with dbplyr for working with the databases with the dplyr package. Reprex tidyverse. There's really no question to me. These are a tidyverse set of packages, almost all of them. For FS, for working with file systems, clipr is Jenny Bryan's package for creating reproducible examples. Most of these are packages that were installed a good deal more in the US than they were in India on a relative scale. All right, so that's one side. Now, what was installed more in India? Okay, we have, I don't remember what CA Tools does. Statistics, this is probably moving window statistics. I'm more familiar with RCPP role for this. It's an orphaned package. Okay, and we also have BitOps, labeling, GTable. I'm a little less familiar with some of these. Some of these I think might be influenced by being related to ggplot2. I'm not 100% sure. But yes, some of these we have as much as a twofold difference in terms of being installed more in India than they are in the US. I would often take this and view it. We could make it a bar plot, but yeah, these are some of the packages that are more installed in India relative to the US. So it looks like some tidyverse stuff more US, some various kinds of packages, a lot of things around visualization, certainly. That's a little, I think that's just a little interesting. And some of the things in the middle. ggplot2 is pretty even. Readr pretty even. So it's not that the whole tidyverse is shifted in one direction. It's more the tidyverse package itself is shifted. Okay, you can imagine a lot of really, if we aggregated across many days, we'd probably get a little bit better data. We'd clean it up a little. We'd deal some with the dependencies, and we could find out more by these comparisons of packages and countries. So that concludes the time we have today. I definitely was really interested in terms of looking at our installations. We can see that this data is very meaningful, but some of it might be a little misleading. Some of it, for example, around the installations, it looks like we can't necessarily trust the IP ID because it looks like it comes from many different countries. We're not able to look at packages over time with this approach because I was just downloading 1 day of packages. But if we're interested in that, there is the cran logs package. I don't think I have it installed. Nope, I do. And cran logs has we could take cran downloads from, say, I don't know, packages equals. I can take one of my own packages and when equals last week and find out number of installations per day. So this is definitely really interesting data. I could have grabbed a set of packages, ggplot2 and Broom is one of my own packages, and looked at the change in time over time. I would have been very interested to learn things like Broom's installed by many people every day, but it looks like most of them probably just got it by installing the tidyverse, since if you install tidyverse, you install Broom as well. I could have looked at a lot of things like that. Again, the reason I didn't look at package installations over time is that I've done that before, and I wanted to avoid being too biased with work I'd already done. This approach doesn't work. The code rather does not work. It must have broken sometime in the last 3.5 years since anyone's done anything with this, and but we can see that it uses the cran logs package, and gets the end. Actually, does it use the cran logs package? I think it does. It's up there. It is. It's been a very long time, but we really did take a look through a lot of things around installations of R, how it's changed over time in terms of number of installations, what countries have visited it. We found some data integrity issues, and not necessarily data integrity. We saw that there's this interesting spike that appears across a lot of countries and a lot of IPs, and we're not sure what necessarily to make of it. We also learned about versions, and I think one of the prettiest and clearest graphs we made was this graph of change by version. I'm gonna put it back on one facet where we said, yes, no question, people usually install whatever version is newest, with a smaller floor of people installing other variations. And then we do see there's something that changes a couple of months ago. Okay, so thanks so much for joining me for another Tidy Tuesday screencast. I had loads of fun. Really love digging into data in R, about R, and I'll see you all next week.